So good afternoon, everyone. Now we are going to start the meeting. Thank you again for thank you all who have joined. And now I invite Dr. Arun Kumar, who is a scientific officer in the School of Chemical Science. And in fact, in the past, we have interacted quite a lot about the chemical waste that we are generating in the campus, and he has shown a lot of his concerns on how we can improve the situation in NISER. So this is our 5th day of Swachhata Pakhwada that we are observing in NISER campus, and would not have any better person than Dr. Arun Kumar, who takes personal interest in all these things. So with this brief introduction, I directly invite Dr. Arun Kumar to start his presentation on the hazardous chemical hazardous waste management in NISER campus. So it's over to you, Dr. Arun Kumar. Now you can put your camera on and start the presentation.
Yeah, I will. I'm sharing the screen right now. Thank you, Dr. Amrin, for such introduction. And this is a really very nice initiative taken by Swachhata Committee, Swachhata Pakhwada Committee, and you put all waste concerns and segregated by departments, segregated by type of waste. And for me, it's a chemical hazardous waste management at SCS. I'm very happy to take up this topic, and now I'm presenting in front of you all. So as you mentioned, this is the 5th lecture of this waste series. I'll try to include several things, several waste materials produced in School of Chemical Sciences, and let you know about the segregation procedure and how to come up with some proper solution to manage the chemical waste. The big challenge is how to manage and how to come out with some solution for the waste. But here, the big challenge, one of the big challenges is automatically solved, that the source is very limited. Though we are producing huge, but the source is very limited. The first source is research and teaching laboratories, and second source is chemical store. So the research and teaching laboratories are sharing most of the chemical waste, that is around more than 95%, and remaining less than 5% is coming out from the chemical store. People may be anxious to know how come it's coming from chemical store. The waste is coming from chemical store. So I would like to explain over here. There are few bottles which get expires by time. So that is considered as a waste. Some bottles cracks, some container cracks, then chemical goes into the waste. So in that way, the waste are produced inside the chemical store also. So this is the small segregation about the waste. Now I'm coming to big picture of the segregation of the waste. It has, I divided into 3 parts. First of all, the first part is identification of waste. That is really very important, how to identify the waste. Second is tracking from cradle to grave, from generating source to the full management of the waste. The third is policy, making policy to manage the waste, setting some standard, making some rules, and handle the waste. Okay, so these 3 things are really necessary to take care of or to manage the waste. So now come to the identification of waste. So the waste are, the chemical hazardous waste are majorly identified into 3 classes: solid, liquid, and others. Others is very big. Others have a very big list that I will explain in coming slides. Solid constitutes around 30% of the total chemical hazardous waste, while liquid constitutes around 60% of total chemical hazardous waste, and other is around 10%. Now, tracking from cradle to grave. So our major sources, as I mentioned, are the teaching laboratories and the research laboratories. And that is the generating source. Second is the transfer, the waste from the laboratories to the satellite storage area. So we have some satellite storage area. In front of mathematics, there are small gas chambers. So 2 gas chambers are taken for chemical waste storage. That is satellite waste storage inside our campus. So now I want to include here safety level. How much safety level is required to handle these waste on these 3 different levels? In labs, you need 35% of the safety level. While transferring the waste from laboratories to the satellite area, you need 50% of the safety level. And while storing inside the satellite storage area, you have to fix at least 15% of the safety level. So your chemical, whosoever is producing, all chemical waste will be safely handled from the labs to the satellite storage area. Now, this policy setting and setting standards and making the policies are also having a lot of safety rules. These safety rules are well documented at the university levels, at the college levels, the country levels. So all the countries, the developed countries, I mean to say, they have their own safety standards, their own safety policies, and their own waste handling procedures. In India, I have gone through several, but I couldn't find concrete, though there are, but concrete, I mean to say, it's not functional on each and every institutes and in each and every colleges. It's functional in some of the colleges and universities or institutes, but in Odisha, I found it's really very difficult. But somehow, by taking all those safety policies, standards, knowledge, whatsoever. So if I will consider that the material is around 100%, all the safety rules constitutes around 100%, then handling solid waste constitutes around 80% of the safety rules and materials. So one must know around 80% of those standards, those policies, those things of the safety rules. And out of 1 to scale 10, around 7 to 7.5 sincerity and knowledge is required. Knowledge includes awareness, which we are doing right now. And for the liquid waste, it goes to around 60% of the safety rules, well-documented safety rules, and 5 to 6% of the sincerity and knowledge. And others, little less. And for the municipal waste, you need very less safety rules, very less knowledge. Means you have to go through very few pages of the safety rules, and you must know some of the points. Like everybody can handle the municipal waste. The other waste, for that we need semi-skilled person. For liquid and solid waste, we need a very skilled person. So since we need very skilled person, so identification of waste is the responsibilities of all laboratory personnel, whosoever is working inside laboratories. Starting from supervisor, lab mentor, to the last working person of the laboratory, last working student of the laboratory, last working attendant of the laboratory, whosoever are involved with laboratory facilities, working inside the laboratories, it's their responsibility. So I tried to come out with some points how to identify these waste. So some of the general points are mentioned here in two categories, A and B. A is physical description. Physical descriptions, by seeing the waste, you can identify it like solid or liquid, or you can say if some level is there, then you can say that this comes under other categories. Whether the waste is water reactive, whether the waste is water soluble, what is the pH of the waste, how much flammable, does it contains heavy metals. This all comes in category A. And now category B, the presence of oxidizer, sulfides or cyanides, halogens, biohazardous materials. There are some chemicals which are really biohazardous, toxic constituents, polychlorinated biphenyls, and highly ordered compound. Those smells very strong are foul smelling chemicals. So foul smelling is also a kind of hazardous. So this is the way to identify in general way the chemical waste. Now I'm coming to the first category, solid waste. Solid waste can further be divided into several parts, categorized, the better word is categorized, can categorize into several parts. Am I audible, Dr. Amrin? Hello?
Yes, you are audible, yes.
Yeah.
You're audible, but if
The
you can
complete
put
silence, so yeah, I thought of checking it.
yeah, please put your camera also on.
Yeah, okay, that's good. Yeah, solid waste. So solid waste can again categorized into several parts, several categories. First one is innocuous waste, that is non-hazardous waste, but there are some conditions which I'll explain. Then the solid waste, then the sludge. Sludge is semi-solid. Broken glasswares are also solid waste. Sharps also comes under the solid waste. Then some of non-categorized solid waste. These constitutes some percentage in our campus, like innocuous waste is around 15%. These all are approximate, not accurate. But anyway, yeah, it has some percentage. Innocuous waste is 15%, solid hazardous waste is around 25%, sludge is more, that is 35%. Broken glassware and sharp constitutes around 15%, others around 10%. This is percentage contribution, but there is another graph line below the green. There is a blue graph line that is on a scale of 10, it has some number. So this number denotes how much these wastes are having ignitability, corrosivity, reactivity, and toxicity factor. So to the scale of 1 to 10, the sludge is most, that is 9.5, more than 9. And solid is around 9. So either it's ignitable or corrosive or reactive or toxic in nature. Somehow it's around 9. And innocuous, I told you that it is non-hazardous waste, but there are some conditions. So if conditions will not be put on, then it will be around 6 on the scale of 1 to 10. Broken glasswares are 7. Normally, the glass breaks, the apparatus breaks while working. So it used to have some contamination on the glass surface. So that constitutes around 7% of the total available waste quantity. 7 out of the 10. Sharp around 4. And I do not have any this factor for others. So as I was discussing about innocuous waste, that has some conditions. If you will put condition, then these wastes are non-hazardous waste. So certain substances with concentrations less than the listed quantity in milligram per liter can be poured down the drain. Like arsenic cadmium is less, quite less. You need to have very, very less quantity. That if it is 0.003 milligram per liter, then you can pour down the drain. These are the permissible level. So for zinc and ammonia, it is quite huge. So you can drain quite huge quantity of ammonia. Zinc little over 0.1%, 0.1 milligram per liter, copper 0.061. So likewise, the others. So, but quantity, if quantities are more than that, then this is not permissible. Then this will be proper chemical waste. Now come to the acid. Acid, if the pH level is more than 4, then you can pour down the acid inside the drain. If less, then it's hazardous. Likewise, alkali, if pH is less than 10, then you can pour down the drain. More than that will be dangerous. Harmless inorganic salt, for example, sodium chloride, sodium carbonate, sodium bicarbonate, that is the baking soda, can be poured down the drain if you think that these inorganic salts are diluted. So in diluted form, you can pour down inside the drain, but you cannot pour down like 100 gram, 200 gram at a time. In a small quantity you can pour. Hypochlorite solutions frequently used nowadays for the as a surface disinfectant in view of COVID. That is also dangerous if it is concentrated. It's highly dangerous if it is concentrated. But if the quantity is quite less, means if highly diluted, like 10 power minus 5, 10 power minus 6 ml per liter, then it can be poured down inside the drain. More concentration will disturb the sewage system. It will disturb the plant life. So one has to be very careful while pouring down the hypochlorite solutions. Alcohol, direct alcohol can also be poured inside the drain, but one has to make sure it should be below 24%. And alcohol containing salt like sodium methoxide, direct alcohol salt, or some alcohol containing salt can also be poured down inside the drain when it is diluted. Fine TLC grade silica or alumina can also be poured down inside the drain. It should be less than 1 gram in all the cases. So this is innocuous waste. When you'll put all these conditions, then these are non-hazardous waste. Now the next in the solid waste category is chemical sludge, solid chemical waste, glass salt, etc. Etc. has so many things that it covers the other category also. So yeah, it constitutes some percentage. Like chemical sludge constitutes around half of the total chemical solid waste. Direct solid constitutes around 30%, and glass salt constitutes around 20%. I tried to put some increasing order. So when you will increase the population of the laboratory, population means it has a lot of meaning, but here I will explain in 2 words, like number of working people inside the laboratories, number of working people in synthetic laboratories, number of working people in organic chemistry laboratory or inorganic chemistry laboratory. So it has a lot of factors. If you increase the number, then the quantity of waste will increase automatically. This is very general concept. But you can decrease by putting some control, having some sincerity, and spreading some words like awareness and knowledge. I have given some example for the broken glassware. I already mentioned in previous slide. Salt include cannula, needle, and several other stuff. Some other specific chemical spills like mercury, silicon oil, acids, bases, or organic liquids, chemicals in liquid form, chemicals in solid form. So there may be a lot of spills, but specific chemical spills have their separate treatment. How to remove the spill, that I'll explain in further slides. Solid chemical waste and chemical sludge both are almost same. One is solid, another is semi-solid. This sludge may have some amount of solvents. Now I have given some representative common example of solid waste. The list is very lengthy, very long list, but I have given here, I have selected here some examples. I can name it: ammonium vanadate, arsenic acid, arsenic trioxide, carbon disulfide. Arsenic word is famous. Like people know arsenic, chromium, sodium. So that's why I put those things. Carbon disulfide is solvent, dinitrophenol. Fluorine is quite dangerous, can eat the glass even. Nitric oxide, phenylthiourea, potassium cyanide, which is the most toxic salt. Sodium azide, with the heavy metals, it can blast, it can be dangerous. With sodium, it's quite safe. Sodium cyanide, thiosemicarbazide, vanadium oxide, vanadium pentoxide. So these are some representative example. Now I am coming to liquid waste. Liquid waste are, it has two categories. The first kind is solution and solvents. Solutions which have large quantity of chemicals dissolved in. So liquid waste are generally organic solvents having a lot of chemicals dissolved in. Those are solutions. And solvents are those solvents but having a little less quantity of, very less quantity of chemicals. So this is solution and solvent. This is the first category. And again, these two divided into halogenated and non-halogenated categories. So there are a lot of solvents which comes under halogenated categories and others under non-halogenated categories. So that's how it has two kinds and two categories. So all laboratories are producing more than 150 drums per year of these wastes. Solution constitutes around 40 grams per year, solvents around 120 grams per year. And solvents, as I told, both can be categorized into halogenated and non-halogenated. So for the solvent, I have categories: non-halogenated and halogenated. So total liquid waste, for the total liquid waste, non-halogenated constitute around 35%, halogenated constitute around 25%, and solution, which is mixed means halogenated, non-halogenated, around 40%. So examples of some common solvent waste mix are included here: acetaldehyde, acetone, acetonitrile, aniline, benzene, bromoform, butanol, chloroform, 1,4-dioxane, ethyl acetate, ethyl ether, formaldehyde, methyl alcohol, methylene chloride, phenolphthalein. These are some representative examples, but I have category-wise examples over here. Example of halogenated solvent waste that contains fluorine, chlorine, bromine, or iodine are considered as halogenated solvent waste. So it has chloroform, dichloroethane, dichloromethane, perchloroethylene, trichloroethylene, trifluorotoluene. So our chemistry people are very familiar with this solvents. But whosoever are not working in the laboratory, they may not be familiar with these solvents, but they must be familiar with chloroform. So chloro, bromo, iodo, fluoro. So these are halogen compounds. And if it do not contain fluorine, chlorine, bromine, iodine, then it is non-halogenated solvent, like acetonitrile, acetone, cyclohexane, benzene, phenol, dimethyl sulfoxide, methyl alcohol, ethyl alcohol, isopropyl alcohol, hexane, petroleum ether, toluene, xylenes, and tetrahydrofurans. These are two categories depending upon presence of halogen and absence of halogen. Now I'm coming to the third category, that is other waste. Other waste again can be divided into many categories. I have selected few, in fact 5. So the first one is flammable and health threatening. Second is small quantity waste. Can we drain? Can be put down inside the drain? Third is chemical spill, for example, mercury and ions. Third is general trash. These are also hazardous. Fourth is recyclable waste and waste of concern. So I'm coming one by one. Let's have some discussion on these 5 categories. So first one is flammable and health threatening. So these are very much capable of detonation or explosive reactions if it is subjected to a strong initiating source or if heated under confinement. Suppose used oils, silicon oil or synthetic oils. These used oils are generally contaminated with physical or chemical impurities. When it is hot or heated, then the impurities may cause some reactions and it can explode or it can catch fire. Second, sodium, lithium, potassium. It may be as a chunk or maybe as a wire or as a lump. These are extremely reactive with water and producing flammable hydrogen gas that can ignite itself spontaneously and catch fire. So these are dangerous. Now, one more is aerosol. Aerosol is generally the solvent vapors mixed with air or other volatile mixed with air, like LPG mixed with air. So aerosol are sometimes equally dangerous like LPG mixed with air. So it can ignite, catch fire. It can do a lot more danger. And for the human, it causes lethargy, slurred speech, lack of coordination, headache, irritation to eyes, nose, throat, and lungs, giddiness, confusion, fainting, because sometimes you can't smell. But you have a lot of aerosol material around inside the laboratories. So it can cause so many problems to a person. So one has to be very careful while handling these waste or while storing these waste, whether it is properly closed or not, whether it's exposed or closed properly. So now the second is even a small quantity waste. Sometimes people ignore it and they drain inside the sink. That is not good practice. I want to raise some of them. Like any flammable liquid with a flash point less than 60 degrees Celsius cannot be poured down inside the drain. Even with high flash point cannot be, but in a small quantity, people do not care. So it will catch fire when subjected to any ignited material or any hot material. So for example, petroleums. Petroleum include petroleum solvents. A lot of categories of petroleum solvents. Second is fast hydrolyzing carbides, hydrides, sodium, potassium, etc. as mentioned in previous slide, sodium, potassium. In small quantity, they will catch fire. Explosive chemicals, even if it is in a small quantity, it will catch fire, it will explode. Mercury and mercury compounds, never ever throw any small quantity of mercury inside the drain or leave it unattended or leave it spilled on the ground. Rinse it from highly hazardous chemicals. So even in these are in very small quantity, please do not throw inside the sink or drainage. Now, I mentioned the mercury and some oils as a chemical spill. So chemical spill is a threat to harm to life and property. If you have not been trained or do not have the appropriate personal protective equipment, never put yourself or others at risk to clean up a spill. Please, if you are not professional, you are not trained, do not involve yourself. Do not jump as a pioneer to clean the spill. It may be dangerous. If necessary, request assistance with the spill cleanup guidance. If you do not have any option, you can call me. You can contact me by email, or you can call me immediately if I am available around. And if I'm not available around, just call me. I will give you some guidance how to cover up it. So if, and very next day, if I will be available, I will take care of it. The most technical spill removal include oil and mercury. These are really, really very dangerous. And their cleaning is necessary. Proper cleaning is necessary. So if you break a mercury thermometer, or if there is a mercury spill, as I told, do not try to clean it up yourself. Evacuate the area and keep traffic away from walking through the spill site. To clean the mercury spill kit is required. Never throw mercury in the trash or dump it down the drain. Try using non-mercury thermometers if thermometer scale permits, or digital non-mercury thermometer sensors. Some of the general trash. People are thinking that these are not hazardous, but it is also hazardous. Like sugars, agas. Sugars means laboratory sugars, agas, gums, amino acids, and inert solids such as talc, small benchwares, etc. These are looking like non-hazardous, but these are also hazardous in nature. So there should be a general trash container where you can store all these stuff, but this is also hazardous waste. Dry wipes, definitely these are hazardous. Bench papers and mats, empty small containers, unbroken glass containers, pipette tips, and weighing papers, and boards, dry resins, and filter media, etc. These all are considered as hazardous material. Okay, so you can segregate even like the small containers, very small containers. You can clean the small containers and throw inside the municipal waste. If you have a bottle, clean the bottle thoroughly and you operate properly. There should be nothing inside the bottle. Then the bottle can go into the municipal waste. And no free-flowing liquids or items contaminated with silver, arsenic, barium, cadmium, chromium, mercury, or selenium. These are very common. So it's common means these are really specifically very dangerous. And mixed with liquid, separating them is really very difficult. So if something is contaminated, your liquid, some kind of liquid is contaminated with these metals, heavy metals, and you know, do not throw inside the drain. Some of the wastes, chemical wastes, are recyclable in nature. So please recycle as much as possible. Like use dial antifreeze elements, which cannot be recycled inside the laboratories, but there are professionals. Paint, varnish, and paint-related material like paint thinner and stripper, adhesives, spent batteries, spent fluorescent UV and metal halide lamps, mercury-containing instruments. These all are recyclable. So you can find out some proper waste professional and hand over to them. They will recycle it. They will take and recycle it. But never ever discard them in the trash or in the drain. And laboratory solvents. I was discussing about liquid waste. So the major part is the solvent waste. That one was around 120 cans per year. So in our laboratory, teaching laboratory, we are recycling the solvent. And I have given here small data for 2 years, 2018 and 19. For those 2 years, I have good data. And before that, we were recycling, but the data was not like manipulative over here. These 2 years, we had very nice recycling amount. So in 2018, we recycled around 54 liter of solvents, and 2019 we recycled around 41 liter of solvents. These solvents includes alcohol, ethyl, and chloroform, ethyl acetate, and some small quantity, in small quantity for other solvents. So if each and every laboratory, research laboratory, will take care of even a very small quantity of solvent for recycling purpose, these recycled solvent can be used for cleaning the glasswares, for cleaning some of the very crude chemical or starting whitish. These recycled solvent can be used. So if every laboratory will contribute, then we can recycle a good quantity of solvent at our end. Now, some of the product I have included here, those raise a concern, my concern, and these are very common universal waste. I consider it as a waste, but I included into the chemical waste. It contains item number 1, antiseptic and disinfectant. I categorize item number 1 as a medical chemical waste. It can be around hospitals, inside the hospitals. Everyone is having in their houses as a first aid kit. They used to have antiseptic and disinfectants. These are also hazardous chemical waste. In large quantity, it's dangerous. So you must throw it on proper place. Proper place means you must find out some suitable waste container, or you can approach health center, there you can dispose it. Second category is herbicides, fungicides, rodenticides, and insecticides. These are used for the purpose to avoid rodents or insects or fungus or herb, some kind of herbs. But one has to be careful whether their food material or drinking water must not be contaminated with these, because these are also chemical waste. Third, dyes, pigments, glazes, inks, thinner, paint, metal polishing. These are also universal waste, but considered as a hazardous chemical waste. Some etching solution and commercial cleaners. People are using bleaching material for cleaning their class. So in large quantity, spillage will be dangerous. So if there is a spillage, clean that material with copious amount of fresh water. Item number 5 contains drain and oven cleaners. That's not very common, but drainage sometimes used to have hazardous chemical waste. It's coming from laboratories. One has to be careful if there is some local effluent treatment plant. So one has to pass, but he has to be careful while passing near effluent treatment plant. Here I have collected some of the Ghs Hazard Pictograms. These are really important pictograms. For these pictograms are available on the chemical bottles, waste bottles, and each pictogram have their own explanation. Like first one is explosive. You can see the fifth one is corrosive. Third one is oxidizing. So whenever the chemical materials are transferred from one place to other place, the suitable pictograms used to be printed on the label. If chemical has 2-3 kind of properties like flammable, oxidizing, and health hazardous, then there used to be 3 pictograms. If there is a 4 kinds of hazardous, then 4 pictograms. So accordingly, they used to put the pictograms on the bottle. Likewise, on the waste drums, it is highly recommended to put some pictograms, some labels. These are globally harmonized system of classification and labeling of chemicals. So it is identified everywhere in the world. It is very helpful to those people who are not expert in chemistry, but involved in the transportation. So whenever they see the pictogram, they used to categorize based on the pictogram and place that particular chemical in designated container. They never misplace somewhere else. So that's how the ship carry all the containers in segregated forms, and our chemicals are transported from one country to another country. So likewise, the waste should also have this kind of pictograms. This will help identifying the waste very easily. So anyway, you must be very familiar. The chemistry people must be very familiar with all these pictograms. Yeah, so in a nutshell, I put here everything together. So the liquid waste is categorized into 2 parts, halogenated and non-halogenated. Solid into 2, solid and sludge, but you can store in single drum. So there are 3 drums. You got 3 drums: halogenated, non-halogenated, and solid and sludge. And for others, you have to have separate drums. For mercury spill, you have to have separate drum because you are not going to have very frequently. So you have one dedicated drum for mercury. You store one time, seal it, lock it, and place it somewhere else till somebody may take. Okay. So likewise for these categories, as I mentioned in previous slides, 5-6 categories, you must have that many number of drums. Like for salts, different kind of drum or different kind of container. For salt, there are commercially available salt containers. There you can store. For glass, you can have wooden box or cotton box. There you can store the glass waste materials. Okay. Municipal waste is very easy. So for that, I'm not explaining anything over here. So in the waste management, there are 3 steps mainly. First step is waste segregation at generation level. That is very, very important, as I mentioned. And second step is satellite waste storage area, which we have in front of mathematics department inside the gas banks, and where we have some caution labels, caution pictures. So one has to be very careful while passing through. They should not play with those drums. I do not know how much it is managed right now, but I know it's mismanaged. So I'm working on that. The day I will find out some solution, I will manage those things. So next is the professional agencies. They usually take the waste and they again segregate the waste. The incinerable waste go to the incineration. Some of the waste go to the treatment. Some of waste go to the permanent storage. So that's how professional handles the waste. Okay. So why we need professional? Does it matter? Yes, because they do analysis and treat the waste accordingly. If that will not be done properly, then what will happen? The uncontrolled and untreated drains discharge directly into the local lakes, streams, and rivers. That is not good. Wastewater treatment plants are not designed to remove chemicals. So if it will go to the sewage treatment plant or wastewater treatment plants, then laboratory chemicals and commercial products can pass through the treatment process. And very easily it will be contaminated everywhere in the environment, in the land, in the water, everywhere. Certain chemicals can upset the wastewater treatment process. So the wastewater treatment plant will not give proper water. The result in raw sewage dumping into the environment. The landfill can leak organic liquids and heavy metals into groundwater. So you cannot landfill it. So somehow you have to hand over it to the professional at the final stage. So these are about the categories and how to handle and where to store. And now few slides about the waste safety. I usually include these slides in chemical safety, and I used to have one small lecture for the newcomers, especially MSc students. Again, I am repeating those slides. So exposure may occur with toxic substance, solvents. Some of them are corrosives, flammables, irritants, carcinogens, mutagens, explosives, radiations, and many, many more. We do not have radioactive chemicals, but yeah, we have radiation causing instruments like X-ray instruments and some other instruments. So one has to be very careful. Now, exposure. Why all these hazards? Overprotection we are talking about. Because exposure to hazardous waste chemicals can result into acute or chronic health effects. How? By mouth, contaminated fingers, by breathing in gases, aerosols, or powder, by skin contact or damage, by absorption through intact skin, by splashes into the eyes, and the most dangerous and very common, water and food, etc. And how you can control, like with chemical safety, the waste safety, and the laboratories are same precautions. Waste management and waste safety rules, one has to follow. Engineering removes or separates hazards from person. Like you have to store in proper waste containers that the waste will be separated from the human. You have to handle the waste inside isolated atmosphere. That will also helpful. And proper storage and disposal system. So your waste storage should be away from the laboratories. Now, third one is administrative procedure that limits production and contact with hazards. Means administration means those kind of experiments which producing a lot of waste should be reconsidered and may be redesigned in such a way that it may produce a less amount of hazardous material. So that is administrative control. Yeah, there are a lot of things comes under administrative controls, which I'm not explaining over here. So yeah, I have some take-home messages for you all. So only use containers that are compatible with the material to be collected. Always label containers with a description of their contents. Do not store incompatible materials together. Do not store waste in the fume hood because that is not a storage cabinet. Provide secondary containment for liquid waste. Always keep the container closed. Okay. Check waste storage area regularly. Inspect containers to make sure that they are not getting brittle or starting to crack. And try to plan ahead. Is there a product or procedure available that will accomplish the task without generating a hazardous waste? And strive for waste minimization. Okay, how? So here I tried to accumulate several things together. So I have some assumptions with my experience and knowledge and awareness and passing through the literature and seeing our waste inside the laboratories. And I have been in other institutes, and I have seen the waste there too. So after accumulating all these steps together, these three big ideas are available in the internet in so many presentations. But I tried to put some numbers here. These numbers are also available in the model slide somewhere else. I got it. But these numbers are approximate. So one can reduce the 100% waste into 60%. In the first step, reduced up to 25%. How? So find out some procedure to recycle and reuse the waste as much as possible, and try to follow the order of priority. So which kind of, like if you have 5 experiments and 5 kind of project work, and 3 kind of project work includes less waste production and 2 others are having high waste production. So try to stick on those 3 which are having less waste production and safely dispose whatever is left. So you can reduce up to 25% of the waste. And now again 7-8% you can reduce by prioritizing some other things, like it includes reuse and recycle, but convert the highly hazardous material into less hazardous. That is also possible. And in the third step, you can again reduce up to 7-8%. We need to use solid waste as wasted resource and hazardous waste as a material that we should not be producing in the first place. So if you have these things in your mind, then you can reduce up to 40% of the waste. It applies on all kinds of waste, not only chemical waste. So finally, I would conclude my presentation with this information, and I want to put disclaimer here. The data used here are still under investigation and not referenced and authenticated yet. So please do not quote or publish them as a valid reference. This is my humble request. Yeah, and it's everyone who can think about the waste, and we can decide the future together. Thank you very much.
Yeah. Thank you very much, Dr. Arun, for a very detailed and very beautiful presentation. In fact, I liked your slides that you have prepared. So it seems that you have taken a lot of effort in preparing the slides and telling us the details of the chemicals that we generate and the implications. So thank you so much. I was just thinking, like, okay, I will ask a few questions for my understanding, because I have very distant relationship with chemicals, or probably I'm completely illiterate in that. So I was thinking whether by diluting all the chemicals, we can reduce the risk, or can it solve our problems?
Sorry, say again, please.
I told that by diluting all the chemicals, putting say water, because you gave us the critical limits, that what is the like permissible limit in a liter of water. So if you dilute all chemicals, then there is no risk.
No. You cannot do with all the chemicals. First of all the chemicals are not soluble in the water.
Okay.
Very few of them are soluble in the water, some salts, and mostly organic, lot of organic chemicals are there. Those are not soluble in the water. And second thing, everything cannot go in the drain. It will distort the water parameter or ground soil parameter up to any level. We can't imagine.
Okay.
Okay, it's really very dangerous. So whatever I mentioned over here, that is some representative example. There are few more, but few more, only few more.
Okay.
So it's a very few percent, 7 to 8% or 10%.
Okay. And then one more question also relating to the mercury thermometer that we use. So suppose that mercury thermometer breaks, okay, and because suppose when the child puts it down and then so that breaks. Now what do we do? How do we handle that? Because
Yeah,
there is mercury.
there are mercury spill kit. One can use mercury spill kit to remove the mercury. Mercury is like very dangerous element, and there is a biomethylation process, okay, by which it can enter inside the body.
Okay.
Okay, and it's really very dangerous. You can Google it and find out a lot of information related to the health.
So we should
That's
not.
why mercury is like considered is the most dangerous in the spill, common spill.
Okay. So that means if it falls down and the thermometer breaks, then we should not use any cloth to wipe that or anything.
If you do not have any option, then use some paper, collect it on the paper along with the sticking materials whatsoever. If it is on soil,
okay, but
okay,
on the floor,
collect it and remove that soil along with that. And before that, you have to wear mask, gloves, and put in a closed container everything, all the waste, even gloves, mask, everything, just
okay.
like coronavirus.
Okay. But if it falls down on our floor in the house,
Then you have to clean it somehow by using papers, and you can use this ash, wooden ash.
okay,
Wooden ash will take out all the sticky mercury from the
okay,
floor.
okay.
Yeah, but you must use gloves and mask.
So that means you will strongly advise to go for using digital thermometers, not
Yes.
mercury ones.
Yeah, mercury should be avoided in all kind of uses.
Okay.
Mercury is very dangerous.
Okay. And again, to know the chemical waste management, now we have seen that you are storing, you are our School of Chemical Science is storing all the chemicals, in those gas chambers or the chambers meant for the gas. But how long can we accumulate this?
No, there is no limit for that. Actually, there are no professional in Odisha.
Okay.
We found recently one professional who is handling industrial waste, NISER Ramki Enviro Private Limited. He's a big guy. He's handling waste for several laboratories in other states. So now they are establishing their plant in Sukinda. There they have plant for industrial waste removal. So they are establishing plant for chemical waste also. So I put some picture over there. So they will take care of our waste. They will segregate. The main challenge is incineration of the chemical. So they used to make a big pit and concrete pit, a very thick concrete pit in several layers. There they store the solid waste for geological time period. Means it will be labeled over there. You cannot use that land, that area, and it will be in kilometers, and it will be undergrounded, that pit. And there they will inject by small pipeline all the solid waste, and it will be there for forever. That is only way to segregate it from the land.
Okay. So, that entire pit will be made of concrete so that it doesn't leach.
Several layers of concrete.
Okay.
And that's why they will incinerate some of the chemicals, because if you will put all kind of chemical inside without knowing, it may blast at some level.
Right. Yes.
So we do not know. It may catch fire at some level.
Yeah,
so they have to. So that's why it's a job of professional. We struggled with pollution control board to find out some solution. They suggested your sister institutes how they are doing, but they also guided us to manage the waste titrating. It is not possible because the level of waste produced over here or any chemistry laboratory are far beyond the local management.
Okay.
It's really difficult to manage at local level. And one more thing I want to mention here, I am complete volunteering here. My job is complete volunteer job here. Though I am in the committee, but I came forward along with some faculty members and I started managing those waste. Now all faculty members are supporting, all students are supporting. So I'm not a leader. Everyone is leader here in our department. And somehow everyone is taking care of the waste. So it's not going to the ground, it's not going to the water. It's the judgment of students. We have circulated the message to all students. It depends upon the sensitivity of the student, how much they are sensitive and how much they are honest to collect the waste. But yeah, it's really very bad. We couldn't find any professional and we stored over there. And by the time the labels are gone. So now the job of professionals will be increased. They have to taste each and every container to find out what kind of waste is inside.
Okay. Okay. So that means at present we are only storing the chemicals. We have no other option, right?
Yeah, we have some dialogues because once we tried to accumulate lot of institute to get that guy was struggling for a license, that Ramki guy. So around 14-15 institutes were collectively had meeting in IIMMT, including NISER. So my initiative was there, and the company people were there. So we discussed, but people, I do not know. It's really hard to say. It's not good platform to say over here. But yeah, people were not serious much. Was too much serious. Yeah, they showed their seriousness, but since after that nothing happened, I would say that I do not know what happening to the waste of their institutes, but at least we are collecting at one place and we are not dumping it anywhere. So we are not polluting our environment. So I am trying to managing some waste at local level also. Like liquid waste is almost reduced to half or less than half. So we are managing the liquid waste somehow. So let's see. We are in situation to find out. I think we have hope. That guy installed some incinerator. So they have given some positive indication that they will take care of our waste.
Okay, so now the floor is open for discussion. If anybody would like to ask anything or supplement anything. Yeah, Vishnu Vishwal.
Hello.
Yeah, I would request you to put your camera on and ask so that we can also see you.
Okay. Thank you, Dr. Arun Kumar. Thank you, Dr. Arun Kumar.
Yeah,
the presentation was very informative, and you have put a lot of effort as.
Yeah.
So, okay, just for the curiosity, I would like to know, like you mentioned that in 2018 and 19, you have recycled some solvents.
Yeah.
Some liquid waste, right? So actually, could you please little bit elaborate, like how you have done it, so that we may follow that, because we are every day generating a lot of.
Yeah. So actually, we have some experiments where we have column.
Okay.
Column separation. So there usually they use a lot of solvents.
Yeah.
So like hexane in ethyl acetate.
Yeah.
So all the separate. So we told the student, please do not throw the solvent in the common waste container, and we collected they were distilling along with their experiment too. So all solvents we have collected in separate drums, all the distillate.
Okay.
And we distilled it by using rotavapors. In the first half, there is no laboratory, so anyone can operate rotavapor from our laboratory staff. So in my supervision, they collect, recycle it, means they rerun it on protavapor, and we collected all those solvents for washing purpose. We use for washing purpose.
Okay.
Because
So,
for washing, you need lot of solvent. Where in laboratory, there's 50, 60 students are working at a time. So you need in liters of solvent to clean up the glassware apparatus.
so basically, like your approach was to, suppose you are washing with acetone, then the acetone should be stored in a particular container, so that with minimum effort we can reuse
No,
that
acetone,
acetone or something.
acetone we are doing. Students are not using acetone for reactions. Acetones we are using for second washing. So that acetones are recycled acetones, always recycled acetones. Sometimes fresh acetones, because we do not have that much acetone in first lot. Okay. So acetone is the major used washing solvent, but that used for the second washing. First washing always with the same solvent, whatever solvent was used in the reaction.
But of course,
That-
there will be
that-
contamination. 2-3 mixture will be there. So
Yeah,
using for
definitely it will
second.
be there. Definitely it will be there, but I have to generalize at some level, so
Yeah.
as the laboratory attendant can do very easily. So my generalization go in that way that laboratory attendant can follow easily. So there is a general rule, whatever solvent they have used in their reactions. So first washing should go with that solvent. Then second washing, if something is still there, then second washing will go with acetone followed by sonication. Then the third washing will go with water and soap solution, because we are not using some standard soap solution, whatever is coming in the market for the glassware cleaning. That requires a huge quantity. Okay, so yeah, and we are having acid bath, base bath also, but that's very rare, for very rare washing.
No. Actually, I was, asking like we recycle. You told that we are recycling, or you are successful in recycling some solvent. So I just was concerned about the purity. Means in order to recycle.
That's why I told along with the presentation, we mostly use for cleaning the glassware, and sometimes clean the. If we are very sure that these solvents are coming from just directly from the washing, if it is pure enough, then you can use for washing the crude materials, very crude materials.
Yeah, understood. Anyway. So another thing, what I noticed that we are, of course, I understand that in our whole institute we do not have proper mechanism. Okay, as you already also mentioned. But the solid waste, if we consider the solid waste, that the contaminated solid waste that we are generating directly, we are putting into the dustbin, right? The big dustbins are there.
No.
Right.
No,
Because I
it's
have seen everywhere in the department, people use the put in the dustbins, in their respective labs, and that is being collected by the person, cleaning person. Okay, like tissue paper, say. If you use some tissue paper and those, I'm not saying the chemicals, direct chemicals, but those tissue papers are also.
That's why I used to have this common presentation several times. Whenever means someone's come forward to tell, it's a duty of all supervisor. They should instruct all the students. They should not do this one. It's a very, very common sense for all the supervisors, all the instructors. They should instruct the student. They should not throw. This is responsibility. All supervisors.
Oh, that's okay. That's okay. I understand that.
Yeah,
But whatever, what
be
has
done in that way. It should not be done in that way, because I have circulated several mails on behalf of safety committee. The solvent should be stored in this way. It should be collected in that way, because I am not very much knowledgeable person for that chemical waste stuff. I have accumulated by reading the literature like others, but people whosoever working as a supervisor, as a mentor, as a faculty member, they also work in some laboratories. They have exposure for foreign laboratories also, and they have exposure for the best management also. They should take care of their laboratory. Then
that's okay. That's okay. I understand your things, but we would like to know actually, somehow how to, how our institute is managing that, because at certain point of time I cannot store.
That's why I mentioned this is my totally volunteering stuff so far. So far, nobody came forward to support me in that way. Some faculty members I requested, they came forward, they they joined with me, and I included registrar. We went to pollution control board to take care of the waste, because if there are 21 laboratories now, and I'm meant for teaching laboratory only.
Yeah.
But slowly, since initially in starting there were very few labs.
No, it is same. It is same. So could you please tell us like how teaching laboratories, because laboratory is same, right? So teaching laboratories handling the solid waste.
We are handling properly in the teaching laboratory. We are having waste containers, proper waste containers, and our lab attendants and all these lab technicians knows very well where the waste should go. Student, they are newcomers. They are not doing some mistakes. PhD students, I also rely upon them, because I can circulate only the instruction, and I cannot interfere in each lab for each and everything, because there are faculty members also who are part of the safety committee. They should also visit sometimes in the lab and find out some mistakes and tell the student. So in that way, the things can be improved. That's what I think. Yeah.
So now we have dedicated area to put our daily use like contaminated tissue papers and other things.
No, that's full. That gas bank is full. That's why we are struggling to find out the professional.
So I'm worried actually. Meanwhile, what we will do, because it will take some time, right? We don't know.
I do not have any option. I discussed in the last meeting. You were there, and there was a minute circulated among all the faculty members. PC Ravi Kumar promised that he will discuss with Works Department and he will find out one more gas bank to collect all the waste.
Okay.
So, and so far nothing happened.
Yeah. So no, because why I said this point, because I have seen that most of the labs actually they are just putting their.
Yeah, it's a good that you raised this thing here. I came to know, and this is really wrong.
And that too, let me finish it. That too, this they are being transported by this tractor. Okay. So outside our building also, if you see, they are just draining the waste on tractor, and where they are taking it, we have no clue and all. And the professionals, the people are involved. They are not wearing gloves, not wearing proper things. Okay, and they are handling. So it is not.
No. Because once I have seen a fire incident.
Okay.
Yeah. One fire incident happened before we joined. Just I think before COVID started. A fire happened in the dustbin, and again I was not there at that time. I was on leave. But next day we had big meeting, and all faculty members were there. So all the faculty members know.
Yeah, of course, everybody knows, but this is somehow neglected here.
I'm very small person to tell all this stuff.
No. You are playing a big role. Okay, don't tell that you are a small person. You are voluntarily doing this. Okay,
actually,
that.
Sometimes sometimes I get irritated. So that's not good for.
No. Yeah. Actually, it is everybody's responsibility, because safety is not for individual person, it is for everybody. So that is why I also instructed my students to join this meeting. Okay, because personally I told them that please for their knowledge this is very important. Okay, because I cannot tell everything at institute level how it is happening and all. So it is good that you have explained many things, but still there are issues, and that we will discuss in separately. So
that's right.
To improve the system at NISER. So that's the thing.
Exactly.
In addition, I have one question connected to Professor Das' question. Like suppose in the mercury spill, because mathematics people say, or somewhere at household or somewhere, say mercury spillage is there, or by breaking the thermometer or so. Do we have centrally, we are keeping some mercury kit, because it is not possible that everybody should buy the mercury kit?
I once invented, nothing happened. I cannot discuss on this platform.
Okay, okay, fine. No, at least if you have this information, so I will collect from you so that I will buy for my lab. Okay, or I will keep
It's
some.
available. Yeah, please, it should be in each lab.
Yes.
That proposal was there. So everybody should keep one if they are using Mercury somehow.
Yes.
By some mean like some passing the nitrogen gas, so they are using pressure generating equipment to pass Mercury.
Because
So
it is obvious that suppose mathematics something happening or physics something happening, they must contact the chemistry people because we are at least more aware.
I will let you not so many people are there. I will let you know one small incident. I was topping up every 6 months the medical kit of each and every laboratory. Medical kit means the first aid box.
First aid.
Every 6 months, I used to purchase some of. I used to collect information from all the lab, what are the requirement, and I used to order and top up every 6 months.
Yeah.
That I was doing with the interest. Now I got a lot of questions from the accounts that it should be entered in the store book. Store people denied that this is consumable item, and the bill was not passed, and I struggled 6 months to get that payment. Okay, now there are a lot of questions from account department. We have health center. Why health center is not doing this job? Because health center is getting some discount on medical items.
Yes.
They are purchasing centrally. I told this is really very nice idea. So I told some student, please discuss with health center. Or you can use your own contingency, but make sure you should get payment back.
Okay.
So this thing was going on routinely. I used to assign some student to collect the information. I myself collecting, and we were buying, and immediately I was sending the bill. And we are also getting 10-15% discount from local medical shop. It's okay. In 5,000, how much health center will get discount, or how much we people will get discount? How much it matters?
Yes.
Yeah,
actually,
in
it should be regulated.
5,000 health center make it 5,005 rupees, 505 rupees. That's
At least it should be regulated. Yeah, as you mentioned, by the health center, because every institute does like that. The safety committee, we are in connection with safety committee, and the health center should do that. And every common places it should be available. So
exactly. No, it's available. It's available. Till now, it's available. In each laboratory we have. But the functional problem is there.
I understand.
It's something really very big. At that day, we were discussing about the safety smoke detector. Functional problem is there.
Yes. Yeah. Anyway, slowly. I don't know why people are not getting serious.
And whatever I am thinking, it should be in the department. Like when you suggested at that day, these all things. Just student came, sir. We need in laboratory that thing. Initially, we started when lab was where we started. So I came to know all these things. So I started buying from consumables or maybe inventing procedure. So I started doing. Slowly, it should increase. It became big. Now things has to be changed. Policy has to be changed. It's okay, acceptable, but it should be functional too. So that is the problem.
I'm also assuring you that whenever we have common meetings and all, I will join hands so that we will try our best to at least
more people will join, then more solution will be like
because I'm more concerned about safety and all. I have put in my lab all the hydrogen sensor, methane sensor, everything sensor I have installed. I have my own fast aid box in my lab, so I am taking care of my lab. But if something happens in the neighbor lab, also we all will be affected. So that or even mathematic people will also be affected if some blast is there or something. So it is all our responsibility to take care of this, and we will do it. Okay, thank you, Dr.
I appreciate your concern too. I appreciate because I love doing all these things, and maybe in that way I am getting a lot of job to work with, but I don't mind that thing. Okay, because I love them.
Yeah. Thank you very much. And maybe students have questions or something like concern.
Sure. If someone is
having, thank you very much.
Yeah, welcome.
So, will anybody else like to ask anything? No. So, if there are no other questions, then we may close the meeting because it's already 5:30, and we had in fact we had the longest interaction in last 5 days, because 1.5 hours we never did. So because you could really provoke people, and I think the PPTs that you have made, so it was full detailed information we had, and I'm sure the students, I think many students have joined from School of Chemical Sciences, so they would take interest in managing the chemical waste properly. So with this, again, I thank Dr. Arun Kumar for educating us about the chemical waste management in our campus. So with this, we shall conclude. Thank you so much.
Yeah, thanks a lot. And I am thankful whosoever has joined here and whosoever will get some of benefit. Thank you very much.
Yeah. Thank you all participants. Thank you very much.